Myself Tejmal Mahal. I am here to introduce the subject, that is the principles of design, that is the second year's chemical engineering subject, which included in the second semester of second year. Here, this course is required the basic knowledge of the material and property and knowledge about the stress, strain and load, and the knowledge of the mechanical engineering which is required for that subject. In that subject, there is a first, that is the basic consideration in the design. In that unit, we have covered the concept of stress, strain, modulus of elasticity, and many points we have to cover in that first unit, that is the basic consideration in the design. Now we will start the one concept that is known as the stress. The stress are the expressed as the ratio of the applied force divided by the resistance area. Whenever the stress is applied on the any force which can be divided into the resistance area, and stress is generally denoted by the psi, and psi is equal to force upon area. It is a mathematical notation for the stress is known as the force per unit area. And for the stress, there are the unit like as Newton per meter square, or that is also known as the Pascal. And another that is the units like as 1 kPa is equal to 1000 Pascal, 1 megapascal is equal to 10 raised to 6 Pascal is there. Okay, this is the uh, concept regarding the stress. Now we will move towards some terminology which belongs to the stress. Uh, in that there are the stressor capacity, stress load. These are the some terminology. A stressor is anything that has effect the causing of stress. Stressor is the any object or any substance which affect the causing of stress. Means any object which implement the force on that surface or object that can cause for the stress. That substance or that element is known as the stressor. Okay. After that, second terminology is the stress capacity. When unclear precious how much stress a person can be carried, since each person has some stresses in their lives. We say he or she has the capacity for stress. Similar in the case of rock and capacity of they have also bring stresses, and that known as the terminology as a stress capacity. Means any object, it may be person, it may be any substance, it may be any atom or any uh, case, like as example here there is a person and rock, that element have the capacity to produce the stress, and that is known as the stress capacity. Okay, this is the second terminology in the stress. After that, stress load. Everyone, even children, must carrying some amount of stress in their daily lives. When we think the stresses as having an amount or quantity, that we refer this is as the person stress load. And here in the case of the any object like as rock, we say that the how much an already existing stress is applied on a rock, that is concept is known as the stress load. Okay, this is the some simple concept like as stress load. Whenever in some person shows that we have stress. Similarly, some object which is placed on a other substance, that is also exert the load, and that load which is carried as a stress load. Okay, this is the third terminology which is belongs to the. After that, there are the some types of stresses. There are two types of stresses, means one is the normal stress and second is the combined stress. Okay, in that normal stress, they are divided into the two parts. There is a one is the tensile stress, second is the compressive stress. These are comes under the normal stress. After that, second type of stress, that is known as the combined stress, and in that combined stress, that is divided into the two parts. There is a shear stress or torsional stress. Okay, and that two stresses are come under the combined stress. We will learn about that all stresses, all mathematical equation regarding the their type of stresses in the further slide. Okay. Now we will in this slide we will take as a normal stresses. The resistance area is perpendicular to the applied force, that is known as the uh, normal stress. Means on the earth surface a person standing as a perpendicular, means like as horizontal, and there is a maintaining of 90-degree angle, that stress is generally known as the normal stress, and resisting area is perpendicular to the applied force, that is one, that is known as the normal stress. But in the normal stress there are the two types, one is the tensile stress and second is the compressive stress. In the tensile stress, it is the stress induced in the body when the subjected to equal and opposite pulls, that is the tensile force, as a result which is there is a tendency to increase in length. Okay, that tensile stress I will also explain in the figure form, so you can get the exact idea what is the tensile stress. Okay, and tensile stress act as a normal to the area and pull on the area. Okay, this is the second tensile stress observation. After that, in the normal stress there is a compressive stress. The stresses induced in the body when the subjected to the two equal and opposite forces, as a result of which there is a tendency of increasing in the length of the body. Whenever the compressive stress is occur on the body that are subjected to the equal and opposite forces, means uh, equally an opposite stress is implemented on the compressive stress, and that tendency increase the length of the body, means whenever the compression is taken place the body decrease its length. Okay, I will explain the similar way in the diagram regarding the compressive stress in the next slide, and it is it act and the compressive stress also act as a normal, and it pushes on the area, means in the tensile stress they are pull the area, means stressing, and in the compressive they are compressing. Okay, that are generally normal stress, and that stress is divided into the two parts like as tensile stress and compressive. Okay, after that there is a combined stress. Okay, normal stress, after that there is a combined stress. Now a condition of the stress that cannot be represented by the single resultant stress, means whenever the stress is implied on any surface that cannot be represented as a single, means number of people standing in the row, that stress cannot be taken as a single stress, and that stress is known as the combined stress. In the combined stress there are the two types, one is the shear stress and second is the torsional stress. Okay, in the shear stress the force is parallel to the area of resisting force causes by the shearing stress. Example like as number of means standing in the row on the earth surface, that is the parallel force, and applied on the that area resisting the force is called as shearing stress. Okay, it is the differ as a tensile stress. Before we studied the tensile stress, that is pull and push combination in the tensile as well as compressive stress, but it is differ which are caused by the force is perpendicular to the area at which they are. Okay, in the tensile and compression there is a pull and push by the horizontal direction, but in the combined stress there is a perpendicular direction. That is the main difference of the combined. After that, shearing stress is also known as a tangential stress. Okay, tangential stress means that is the perpendicular type. After that, combined stress is divided into second type, that is known as the torsional stress. The stresses and deformation induced in the circular shaft by the twisting movement means, example like as any rubber band which you have and you get twisting. After twisting, the rubber thickness get reduced and we implement any other force or more twisting, that rubber that can elongated and cut down into the two pieces. Same that torsional stress is generally occur any thread, any wire which is uh, implemented as a stress by the twisting means opposite movement of that uh, circular shaft, and deformation get introduced in that uh, circular shaft or any circular rod, that is known as the torsional stress. After okay, these are the some diagram where the tensional stress, compression stress and shear stress is there. Okay, here the tensional stress means the pulling action is carried out. The arrow shows the pulling opposite direction. Hence the any surface area get elongated, and at the certain time that selected area get into the crack, and uh, tensional stress is created. Similarly, compression, whenever the pushing means arrow shows the both arrow pushing inside the block, and uh, molecule get contracted, and whenever the its sustainable capacity is over, then the molecule get distorted or deformed, and we get the like as the compression stress, as well as there is a shear stress, that is known as the standard tangential stress. Okay, where the equal and opposite force means any cube there is a tangential means by using the opposite side, and implemented by the different section there is a breaking of that block into two pieces, one move that side and one move towards the side, that get by using the shear stress. Okay, after that stress there is a concept for the design that is known as the strain. When the body is subjected to the some extent force, there is a some change in the dimension of the body. The ratio is a ratio of the change in the dimension of body to its original dimension is called as a strain. Means whenever the external force get in a body, that some changes is occur, means some ratio changes dimension of body is changes into the original dimension. Means example like as balloon we hold into the hand and we pressing it, uh, the dimension of the that balloon get changes, and strain is known as the dimensionless quantity. Okay, after that, some terminology which include the strain, the longitudinal and linear strain. The strain that changes the length and line without changing the direction, that is either the compressional or tensional, and that is known as the longitudinal or linear strain, means the strain which is applied by the horizontal way. After that there is a compression. The compression, whenever the longitudinal strain and shorten the subject, means similar like as a compression stress, similar like a strain is developed by the longitudinal stress. After that, tension stress. The longitudinal strain, that length of the subject get increases, that is known as the tension, means the pulling is implemented on that selected portion of the, okay. Shear, the strain that changes the angle of the subject, sorry, the change of the angle of an object, that is known as uh, shear. And shear is the causes that lines to rotate. And there is a next terminology is the infinitesimal strain, the strain that is very tiny and few percent and very less, allow the number of useful mathematical simplification and approximation, that is known as the infinitesimal strain. After that, finite strain, the strain is larger than few percent, means whenever the previous concept where the low percent is clear, but which is low percent which is converted into the larger, that is known as finite strain, and that require more complicated mathematical treatment than the infinitesimal strain, okay, and that is known as the finite. After that there is the next concept, that is known as the homogeneous strain, and in that the homogeneous strain is known as the uniform strain, whenever the straight line in the original object remain in the straight form, the parallel line remain in the parallel form, circles are deformed into the ellipse, that is known as also homogeneous strain. Note that the this definition rules out the folding, since the original strain layer has to be remain straight. Whenever the we implement the force, that all object or any substance that is into the parallel or circle shape, that are into the straight layer, and that is known as the homogeneous. After that there is a next concept is the inhomogeneous, how the real geology behavior, means the contraction and expansion of the earthquake, and that is known as the inhomogeneous strain. The deformation takes place, means the rock comes slider down, that known as the inhomogeneous strain. The line may be bent, do not necessarily remain parallel. In the inhomogeneous way, there is a bend taken place, as well as the non-parallel system which is developed, and that concept is known as the inhomogeneous. After that, some types of strain is there. There is a tensile strain, second is the compression strain, third one is the volumetric strain, and fourth one is the shear strain. We will describe in detail next slide. Okay, now the tensile stress. This is the first type of the strain, that is known as the tensile strain. The ratio of the increasing in the length to the to the original length of the body when it is subjected to the pull force. There is a important pull force when the tensile strain is equal to increase in length divided by original length, that is dl by l, and that is known as the tensile strain. After that, second type is the compressive strain, the ratio of the decreasing in the length to the original length of the body when subjected to push force. Here important is a push force, and the compression strain, that is equal to decrease in length divided by original length, that is also dl by l, that is known as the compression stress. After that, third type of strain is the volumetric strain. Whenever the ratio is change of the volume to the original volume, that is known as the volumetric strain, and mathematically that is known as the volumetric strain is equal to dV by the V. And these are the three types. Fourth types is remaining, but that has different, so we cannot taken as a here. The diagram, which is simply known as the pulling force in the push and pull, that are a concept shown in that figure. Here the pressure implementing the pulling, and here the pushing, that is the force is exerted, where the tensile strain and compressive strain is occur. Okay, and after that volumetric strain, that is change in volume. You seen the upper volume is there, and whenever the changes in volume is taken place, the dV is exerted, and the volumetric strain is divided dV by d. Similarly here dl by L. Okay, these are the three strain. After that is known as the shear stress. The strain due to the shear stress is known as the shear strain. The diagram shows the cubic is there, but some angle of deflection is there, and blue line is that is surface is created due to the force is implemented, because the shear is implemented. And the sign convention for the direct strain is equal to tensile strain are the consider as a positive in the case of the producing increasing in the length. Okay, whenever the tensile stress which consider as a positive, that causes in the increasing in the length, and the compressive strain are the consider as a negative in the case of producing decrease in length. Okay, whenever we take as a positive for the increasing length, and whenever consider as a negative, then the producing in the decreasing length. After that, there is a last concept regarding the strain and stress. There is a Hooke law and Young modulus. When within the elastic limit, the ratio stress is applied to the strain develop is a constant, and the constant is known as the modulus of elasticity, or Young modulus, or elastic modulus, and that is known as the E, and E is equal to stress upon strain, and that whole concept is known as the Hooke's law, where the Young modulus it is known as E, and generally assume to be same tension and compression, and for the most engineering application is high. The Young modulus, that is E, it should be high. The numerical value, that is the typically E is equal to 210 into 10 raised to 9 Newton per meter square for the steel, and steel has a elastic property, elongation property, and all, so that the here the numerical value as a consider as the 210 into 10 raised to 9 Newton per meter square for the steel. That is the concept that relate the relation between the stress and strain. And I am thank you for watching the video. You can like and subscribe. Thank